Well, hello everyone. We'll just give about a minute here to let some people in. The lobby uh, continues to say admitting, so I'm not sure what's happening there. But thank you for joining us today. Craig, why don't you introduce our topic here, and then we'll jump into about virtual graffiti, about yourself, and then about me before we kick off.
Sure, absolutely. I think everybody can agree that this is a top of mind issue for most organizations out there. The issue of adversarial agents is a huge problem, and it's a growing problem. So this presentation, I did a version of it at Gartner's Risk and Security Symposium in March, and the reactions of the audience was very telling. A lot of people are quite nervous about this prospect. And so during this presentation, I'm going to level set. I'm going to provide a tour of the state of play. It's been updated continuously because even a few weeks in AI land is ancient history. So we'll get a bit of a tour. We'll introduce some hopefully new ideas and talk about some of the high-level mitigations and RSA's response to it.
Fantastic. Yeah, I think we were talking about it the other day, Craig, just how fast and, we probably could have turned on the news this morning and updated a couple of the slides, even with current and existing things that are happening. However, I think some of the basics are still the same. Just to introduce Virtual Graffiti. Virtual Graffiti started as a business in 1999. Advertising network firewalls actually is kind of our first go-to-market. So we had different web stores for SonicWall, for Fortinet, for Palo Alto. That's since expanded into all products and all services that we think are security or cyber related, including authentication. It's hence why we probably work with you so much, Craig. And we've got about 5,000 plus customers today. So quite a bit of technical knowledge and see quite a few different customer environments day to day. And we've got quite a few engineers to help you in that process as well. Craig, I'll let you introduce yourself. Who are you? What do you do at RSA?
Yeah. I'm the field CTO for Asia Pacific and Japan, pretty wide remit. I've been recently appointed to drive, lead, and most importantly, speak with customers around agentic AI and how to secure it, how to govern it, and then also some other componentry that RSA is unveiling through the year. So I'm a customer facing primarily. But I also interface with the product management team, product marketing, and product engineering. So it's a fairly wide remit that I hold. I'm a very long time technologist, harkening back to when I was 6 years old and being fascinated with digital watches. And right now, I mean, with respect to the massive shift that's undergoing the entire industry or multiple industries, it's become a full-time job just to keep abreast of the things that are happening out there. So that's why I'm here today with one of my favorite partners, Virtual Graffiti. So thank you for having me, Mr. Thad.
No problem. No problem at all. I think today's topic's one we both could riff on for probably days on end here, and how do you secure different Gen AI and all the different things that are vibe coded, and what we're building in our personal lives as well to make life easier. I built a grocery identification app a couple of weeks ago. Something tools that we're using every single day to make life better for ourselves. So it's a crazy time to be working in this space right now. Just to introduce myself, I'm the COO or general manager here at Virtual Graffiti. I've worked both with RSA and a handful of other vendors on their partner advisory councils for their go-to-market strategies. I've worked in IT probably almost 15 years now, predominantly with Gartner leading vendors, and looking forward to chatting AI today. Craig, let me stop sharing and I will hand it off to you to share your screen here. Yep, I see present the autonomy problem, rethinking identity, risk, and control in the AI-driven landscape.
Yeah, quite a mouthful. And I think we'll have multiple mouthfuls today of fairly complex topics. But I'm just so pleased that everybody's taken the time to join us today. I believe that the session is being recorded. And the way that Thad and I historically have done our webinars is that we kind of riff off each other as much as we can. So I, do throw in when you see an opportunity to do so, Thad. And shall we get started?
Yeah, I think so. And as always, if there are any questions along the way, please feel free to ask. I'll be two-part, moderator and speaker within this. So, feel free to interrupt us at any point in time.
Yeah, awesome. If there's a compelling question, certainly type it in for us. We're happy to take them all and hopefully answer them. So let's get started. So thank you very much, Virtual Graffiti. Thank you to all of you for joining. Now, before we get into this tour of the landscape, if you will, I just want to state, like, a lot of it is pretty scary stuff. And I'm not here to sort of spread doom and gloom, but let me kind of cast a ray of light in the messaging here. And this is my firm belief as somebody who's worked across these tools for multiple years and has been using AI for even longer than that, is that I believe that the long game favors the defenders. So not everybody agrees with that assessment, but I'll characterize it this way, is that right now we're in a period of strife, and some people call it a crisis within cybersecurity. A lot of organizations can use AI to improve or automate or create a chatbot for their customers or for their business. But this is entirely optional. But I'll contrast that with cybersecurity. We're in a moment where the use of AI within the domain of cybersecurity is not optional. You have no choice. And the tools that are being used to, say, attack or find vulnerabilities out there are just getting better and better. And obviously finding the vulnerabilities and then going off and fixing them is a pretty hard problem to tackle. But the long game is that the tools used to secure and write the code is only going to get better and better and better, such that reducing the number of gaps or potential exploits in the systems and the software that we use. And I think that the long game is more of a defender-favored approach versus what we're seeing out there today. So that's the ray of light in this long conversation. Before we start, I want to back off of all the details and share with you some of my personal thoughts. And it's shared by multiple people out there, but I like to consolidate it in this way. So right now, we're in a world that we can call the old world. So you have static applications that have been written, SaaS, on-prem, legacy, all that good stuff. And then have like a user interface that sometimes you actually need to read a manual for, and then the infrastructure that serves it underneath. So really static, hand-built interfaces, static applications, and so on. That's the world that we used to live in. And the new world that we are currently living in is all around the experience of prompting. Whatever that prompt is, it could be an image, could be a voice, could be a text, it could be whatever, right? And underneath that, the engine of the new world is basically inference or artificial intelligence or a large language model. And the tools out there are you would really just generally refer to them as agents. So just to kind of characterize that maybe in a different way, most startups, if you go and talk to them these days, most of them are utilizing AI to build their products, build them more efficiently, and build them faster. Now let's cast aside the kind of the security side of them doing that. We'll just cast that aside for a moment. But right now, there's almost a direct path in between whatever your business input is and the value that you get from it. And so the box in the middle, sort of the lower middle there, you would refer to as a neural network or an LLM. And software is built this way. Software is great at building new code because the LLM was trained on software code. So right in the middle, you have AI, but we could also characterize it as a neural network or providing inference across multiple disparate sources. And the best way to kind of describe it is mathematical circuitry. I almost said mathematical security, but that's something different. So mathematical circuitry is basically a neural network, right? And so here's the thing, is that to bring it back to cybersecurity, is that if you are a middling script kiddie or hacker or sort of evil actor, if you will, why would you not use a co-pilot assistant coder that has 30 years of software development experience under your wing? Why wouldn't you use that? And so our adversaries out there are not just using one agent to do something bad. They're using multiples of them. So a lot of people use the term agent swarms. So this is kind of the new world. That's the democratization of software development. It has made it accessible for everybody. And I think, Thad, you are like literally a real life testimonial around this. So you want to sort of share what you've been doing?
I mean, especially with Hermes being out there, you can use Hermes and OpenRouter there's no guardrails on these things, right? Some of the applications that I've been able to go build, are doing day trading for me on the fly, and making real world money in it, or doing scripting for me, or whatever. You're able to accomplish so much in such a small amount of time, and remove these main model guardrails from Claude or ChatGPT, Codex, etc., and just use DeepSeek or any of the Hugging Face models on the go. It's a new day and age when you have 3 AI agents running on your machine, and you're just playing kind of puppet master with them, telling one to orchestrate this, the other to do this job, and the third to do this part of the infrastructure. And then you've got to.
I remember when ChatGPT was kind of new to the world. The way that I characterized it in front of audiences that were new to it as well is that you would be the conductor in an orchestra of AI agents. So the human in the loop is, deciding what to build and what direction to go. And then the agents just go off and do all the work. And testimonial is my, 10-year-old daughter wrote an Android app using Codex, and she doesn't even know what software development is. She's never even seen source code, but she was able to do that with minimal intervention from me, and actually develop a cute little app for her brother. So, we're in this new world. It's quite exciting. And then, of course, with all new tools, there's always kind of a downside. But what we're doing out there, if you look at this kind of right at the top of infrastructure that we're building, this is new infrastructure, which is heavily centered on the top 2 coordinates there. So you have prompt and your LLM, if you will. So whatever that is. And underneath it is your agents or multiple of them, and then the infrastructure that serves this. This is kind of new stuff. Everything above infrastructure is new, and how it uses your infrastructure is new. So I'm going to bring this back to cybersecurity. The most important things with respect to the 2 sides of the coin. So, and the 2 sides are, if you have an external actor performing adversarial actions against an organization or you or whatever, but also an organization's own use of their own agents. So the agents going off the rails and doing something out of scope, or doing something to their own business. So there's a great example of an engineer at Meta who actually ended up deleting their entire email inbox forever, right? So this is an agent that goes off the rails. So there's 2 sides to the coin, and in order to ensure that an organization is ready to respond to, say, adversarial attacks, a correlation is probably, having monitoring in place is kind of table stakes, but being able to correlate something that might be attacking you, everything, everywhere, all at once, is where correlation comes in. And I'm going to admit something, is that I don't believe that the cybersecurity industry or the tools that do these kinds of things have really quite caught up to the needs of the market right now. And that's why a lot of organizations are scrambling in order to build up their own capabilities in order to answer that question. So let's continue on just really quickly. I think one of the key things around, say, your own use of agents or how an agent could be turned against you, and I'll talk about that later, is inventory. Knowing where they are, what they touch, and what they're not allowed to touch. Inventory and having a strict regime of policy, you might call it a control plane in terms of, scoping and restricting agents and what they can do and touch, right? And then if you refer to the broader identity program, all of the aspects that you see in the slide should be wrapped around a sort of the broad IAM program. And that includes the use of APIs, which is how agents typically operate, and then OAuth tokens and other technical elements with respect to software development. And then finally, human in the loop, and having a human that's available and is mandated for critical operations. You don't want to spam the human for everything the agent is trying to do. As long as that agent is properly scoped and then it tries to go off the rails, that's when you would have human MFA or human in the loop for that use case. Now, here's the thing, is that this picture, this is infrastructure, is that trust of all of these things is the bedrock for responsible use of agents and, of course, ensuring that your organization isn't going to get completely owned when being attacked by other organizations. So this is the big picture ideas, but this I think it's quite accurate to sort of display it in this manner. Trust is absolutely foundational to everything that we do going forward. So now let's really get into the cybersecurity conversation here. And so what I like to do is just basically talk about a bunch of different threats. So I kind of put them into three buckets, if you will, ranging from the same old, all the way to, we're off the reservations. So everything in between. So let me just define this. How are organizations getting attacked these days? Well, obviously, number one is phishing. I think everybody on this call has done their security awareness training and knows what phishing is and how to spot it and so on. But the reason that these are so prevalent is simply because they work. They can attackers or threat actors can spam organizations and fail multiple times until they just succeed the one time. And so there's countless examples of well-resourced organizations or even small ones getting owned in this way. Organizations that might or should have known better. The next part is kind of moving a little bit to the right in terms of the techniques that attackers are using. And I'm just going to call out one of them, is rather than attacking the actual organization that they're going after, they're actually attacking their MSP or their managed service provider. So they attack a smaller organizations that's sort of adjacent to the main one in order to gain access. And we've seen multiple examples of this being done. MGM Grand in Las Vegas is a classic example, huge breach that occurred as a result of being attacked via a third party that was owned.
And then finally, it's huge, Craig. Because I think it's like 60+% of all breaches originate from the service provider here instead of at the actual organization.
This, as I mentioned earlier, I did a version of this presentation, and it's obviously kept up to date at Gartner, and that's a rather expanded presentation because it includes mitigations for all of these kinds of things, and especially in the next bucket. And so my invitation to that and your customers is, if you'd like us to do kind of a one-on-one with your organization around more details in terms of mitigation. So I have 9 suggested mitigations and some detection techniques in a sort of the broader presentation here. So that's my invite to you. Anyone on the call that sort of is interested in this, just reach out to Thad and we can perhaps arrange something in future. So obviously we're not in Kansas anymore. We're way off the reservation. And that's when AI is being used as a co-pilot or enabled a fully autonomous compromise. And so we'll talk about that a little bit more in detail. Again, my expanded presentation goes into a lot of detail about what that looks like. But the question is, who's gotten breached? And it's a bit of a challenge to say you got breached because some tool was cooked up by AI and now you got owned. It's because malware, whether it's been authored by AI or not, is still just malware. So it's really hard to tell the difference, but I'll relay some tips a little bit later. But there have been organizations that have been breached in this fashion. So let's level set for a second, because some of you might not really know what an agent is. And I think that we need to kind of level set there. So when asked what is agentic AI, and it's really just, characterized as the use of tools. Because when you talk to ChatGPT or even DeepSeek or Claude, these LLMs have no ability to do things in the digital world. They can't perform operations for you. They need to use a tool. So a lot of the times, the tool is the agent. That's really just like the most blanket definition that you can come up with, right? And so, for example, this is clearly a little bit out of date. Sonnet 4.5 is an LLM. And it's a little bit different than ChatGPT in that it has native agent hooks built into it, such that agentic features can be plugged into it quite easily. Yeah. And so just to kind of sum up what is an agent, I mean, if anybody uses Claude in their personal life, they will see it cooking up agents all the time to do particular tasks like image generation and so on. So, just to kind of round up this idea here is that the brain is the LLM, and the agents are the LLM's hands and feet in terms of doing something. And then, of course, if you have multiple agents, you need a little bit of context. What is your goal? What is your role here? And then, of course, an orchestrator that will help sort of manage it all, right? So that's super high level. As Thad said earlier, we could go on for days about this, and I'm sure you don't want us to do that. So here, this representation, you have Claude engine up at the top. That's a classic Claude logo from Anthropic. And then there's these boxes in the middle, and these MCP things. So what is this MCP thing? So MCP refers to a standard in agents, right? It's basically an agent middleware piece, right? That can either download or create tools that it needs to do things, right? So what is MCP? It's called Model Context Protocol. So you don't need to remember this, but just know that this is kind of the agentic standard out there was basically invented by Google and is used within the context of many organizations. It's a de facto standard, right? So here's a word of caution about MCP. So one of the aspects around MCP is that you can download an MCP server that somebody else cooked up for you. And then there's a public place where you can get these things where it advertises what the MCP server does. So you read an advertisement, say, hey, this thing's going to connect to an Oracle database. That's fantastic. I'm going to use that, right? The problem is a rug pull attack that has been instrumented against MCP servers, and there's countless thousands of these out there, right? And so you'll see these links at the bottom of the screen from Sneak and Agent Seal. They're great security firms that do analysis, and they came up with some really high-level things around their analysis of the MCP ecosystem. And it just kind of can summed up in those 3 ways. It's bad code, bad trust, and bad cognition. So I'll just focus on bad code for a second. This is the rug pull attack. An MCP server advertises what it does, and then some evil actor out there changes what it does. And someone downloads it, and they don't actually know that it's doing bad things. So for an example, somebody attacked an MCP implementation that thousands of people were using, and he or she inserted a blind carbon copy, a BCC, into every message that this MCP server was sending back to them. So every message that was pumped through this code was blindly copying, without anyone's knowledge, every message that was sent through it. So you can see that's a rug pull attack. It advertises one thing and then does another. On the right, you have bad cognition. And I'll talk about that in terms of poisoning the well or poisoning the LLM with deliberately bad data, or being vulnerable to something that we're going to talk about in a second, which is prompt injection. We're going to talk about it now. So what is prompt injection? I'm sure lots of people know what that is, but in case you don't, I'm going to say that every LLM you have ever used, every LLM that you will ever use, is vulnerable to prompt injection. Now, admittedly, the latest, greatest frontier models have some guardrails built in, but just what is prompt injection? So just to characterize it like this, you're having a chat with an LLM and you ask it, how many R's in the word strawberry? And then it says, yeah, I got that for you and I'll write that for you, or whatever, right? So you get the answer back. So that's a good chat. You're just having a straight up chat with the LLM. The bad one is where the threat actor will deliberately subvert the guardrails that are built in. And so a classic example is to tell it to ignore all previous instructions and do something that the LLM was not intended to do. So that's, there's a whole domain of expertise on prompt injection. So no LLM is completely invulnerable to this. And the reason is that every LLM shares a basic architecture. And the architecture is that it cannot separate developer intent with user input. Those are the same thing in the same chat. And so breaking out of that becomes tremendously easy if you know the tricks. So tricks like threatening the LLM or promising a reward for the LLM. It sounds quite bizarre, right? But yeah, so there's one of the jokes I make in terms of sanitizing input for the LLM is that we're going to bring DLP back as a product, right? So that's to Thad. Maybe you'll look at some DLP out there.
We signed some new DLP vendors actually, Craig, but I think we're both guilty of some prompt injection here. That's for sure.
So all sorts of dirty tricks in terms of inbound prompts that use Cyrillic characters to trick the LLM and all that stuff. So one of the plugs that I give, I'm not associated with this organization at all, is an organization called Island. And Island develops a browser plugin and their own browser and their own desktop agent that does exactly what we're talking about, is minimizing the risk of prompt injection within an organization. So it's a chat bot for your chat bot, which is kind of a bit of a joke. So just a plug in there. I have nothing to do with Island, but they seem to be a fairly solid offering out there. So let's talk about some examples. So I'm just going to breeze through this a little bit. As I said earlier, there's a broader presentation that gets into more details, but I'm just going to talk about a report from Anthropic in November of 2025. So again, that's absolutely ancient mythic history here. But they did report that they saw the aspects of Claude being used as the operational engine for a complete attack. So the attack includes things like the kill chain. So the kill chain includes recon, installing stuff, tricking users, and then extracting the data they want, or installing ransomware, and then creating persistence. That's the entire kill chain. And so they detailed all of the aspects to this and said that entire thing was automated. And just a high level, just little plug there, is that part of the recon was not just simply scanning your systems for vulnerabilities. It was literally scraping social media and scraping LinkedIn to determine the individuals who were, say, adjacent to security within the organization and targeting them in a targeted attack. Crazy, right? Automatic, going to social media and LinkedIn to find who's most important and then having the system develop and attack those people. Crazy, right? So the report, I'm not getting into the details of the report, but we can do on your own time, that talks about the tools that were used in context of this sort of fully autonomous attack, and they were not exotic. Things like Nginx and Nmap and all of that good stuff were all used in coordination. Then so mitigations, as I said earlier, if you want to have a discussion about this side of the puzzle, that's something that we would be more than happy to have with you. I've had numerous one-on-one customer sessions where we drive into those two topics in detail. So here's a real-life example of a fairly recent attack that was completely automated, right from exploiting a piece of software, and as I said, recon, install, persistence. You see all of the tick boxes there in the so-called kill chain. And the main thing about this Jade Puffer attack, you can Google this one, is that the attack iterated, which meant it got things wrong and was able to self-correct and do other things at machine speed. Remember how I said everything, everywhere, all at once? This is that in real life. This is a real attack. And just the point is that in the self-correcting example, it literally wrote its own parser to convert the outputs from this Langflow tool into JSON. It wrote a converter itself because it didn't understand XML and converted it to another kind of file format for web coding. So crazy, right? It did this at machine speed. And then second is, and this is a point for all of you, is that when an LLM or typical LLM writes code, it will self-narrate. It will insert comments into its code in order to say, now I'm going to be doing this. It basically self-narrates its chain of thought, right? And so that's a good tell for organizations that might have detected some code that's going off the rails, is because you can detect it using its self-narration function. And there's a link there from Sysdig that talks about the Jade Puffer attack. So that's meant to pop up later, but one thing is, this is a little bit technical here, but when developers develop software, a lot of the time they grabbed the pieces of the building blocks from public repositories. So everybody's probably heard about GitHub. There are other repositories, one called NPM and another called PyPy. And so just this year through to basically yesterday, there's been a set of worms, one called Shai-Hulud, which references the creature from the Dune books and movies, and then copycats. And these just using GitHub features to steal access, basically. So there's an old joke in security is hackers don't break in, they log in. And so when they steal an access key into software repositories, they just can use that as kind of their ticket to get in, right? And so we are in this state right now where there's almost 200 billion monthly downloads of infected packages across these ecosystems, NPM being sort of the most attacked by all of these copycats. So one of the things that from a organizational standpoint is that when it comes to DevOps, it's really just, oh, those devs over there are doing something crazy, right? And that's no longer an acceptable answer. It's DevSecOps or DevSecurityOps must be rolled into the broader IAM program that would exist inside of one's organization. RSA provides IAM programs. We do governance and lifecycle across all of the span of identities and other attributes within your organization. So
I think it's even an issue for us, Craig. The developers want additional control for testing different things. Heck, even sales has asked me for different Python libraries a few times for using Claude code, and I'm like, nah, we're not doing that, guys. That goes
See, if only all organizations were like yours, that
it's a little easier for me to say, well, here's why we can't do that, because we've spent the last 5 years doing security hardening, here. But correct. Not all orgs have that style or
So what?
are able to push
Yeah.
back on that.
So this is a fairly detailed topic, but these are just the basics. And one of the basics around mitigating all this crazy stuff that we're talking about here is really around minimizing the blast radius. You know, when you have an explosion go off and it sort of blows outwards and touches a whole bunch of things. It's the same kind of in terms of an agentic attack or any other kind of characteristic attack. And so just as a summary, is the ability to slow an attack that may be everything everywhere all at once, but having enough gates within your environment in order to slow or stop an attack that might be in progress. Remember, I talked about inventory being a very important aspect to your program, and then correlation being an important aspect of your program. Those two things alone, coupled with proper governance, can do exactly what we're talking about here, minimizing the blast radius. I'll talk about human loop in the moment. And then, of course, rolling machine identities like API keys or system accounts or OAuth bearer tokens into the broader IAM program, because historically these sat largely outside. Oh, you need a REST API key? Here you go. No audit, no recording of anything. And so from the human in the loop aspect, that's something that RSA is pretty well known for. But what we aren't well known for is developing modern authentication with no cloud involved. So many people will know that RSA Secure ID has a cloud service where it has FIDO passkey support there. What we're developing is the ability for you to kind of do all of that crazy awesome stuff, but just bring it into your own environment, deploy it anywhere you want. And so obviously human phishing resistant MFA is part of that human in the loop equation, and RSA are the expert in that. And so continuing on, talking about machine identities, we've already kind of said that. Here's some tips, is that for anybody who's sort of more knowledgeable about that, is OAuth bearer tokens are basically just a key that you hand over to someone in order for them to get access and download code and all that stuff. The word ephemeral just means temporary, but characteristic or historically, these access keys are non-ephemeral. That means that they last forever, and there's no logging or any kind of management or governance around that. So bring that home. Bring that into your environment and do some inspection there. I'm running out of time, so there's one kind of last piece that I want to just talk about before I finish up, is that RSA also provides a live human challenge, which that means that if you're in the midst of doing something, say privileged, or you say ring up the help desk, Thad rings me up and says, hey, I need to access this new application. I can say, okay, Thad, that's great. I'm going to send you a challenge to your phone that you need to respond to with your registered device. So RSA can actually provide that live verification in context of whatever it is that a user is trying to do, right? So here's our kind of, let's say, recommendations is, as I said, inventory is absolutely critical because you can't manage what you can't see, right? And then having a continuous discovery of agents with the environment. This is absolutely critical, both from an adversarial standpoint and an internal use standpoint. Human in the loop, I will characterize that as kind of a giant magic pause button for, say, reducing agent sprawl. So being able to require human intervention, not for every operation that an agent might be doing, but human intervention when it tries to access a critical tool or an escalated operation. Yeah, and I think that's pretty much, RSA is famous for applying security policy in order to enforce strong MFA and human in the loop wherever possible. So this is kind of core to our business. And then finally, governance of everything that we've been talking about today, and enabling a real-time authorization of that capability across an organization, and foundationally, being able to have traceability against what it does. And so stay tuned magic hands in front of you. Stay tuned from RSA around what we are soon to be doing in these three categories. Right. So let's wrap this up, Mr. Thad. I'd like to leave you with a report from July from the Australian Signals Directorate. So they run the Australian cyber capability and provide industry guidance. And just some highlights, talks about overly privileged agents in your organization. God talks about exactly what I've been talking about, these stolen access keys to get software or access into a privileged API. And then, not real-time entitlement checks. Is that tool allowed to do that, or is it still allowed to do that? So I really, really recommend that those on the call here have a look at this report. It is excellent, but it does summarize that agent capabilities more stem not from the model that you're using, Claude, ChatGPT, DeepSeek, but it's actually about the harness and how that gets orchestrated within your environment. So we've got, you've heard the hype about Mythos and Fable and GPT 5.6. It's kind of like Coke and Pepsi. It's, you can use use them both for your own kind of purposes in the cybersecurity domain. But here's the thing about these tools is that they're great for the attackers too. And we all know that, despite the guardrails and all that stuff. They're great for defenders, but unfortunately, they're great for everybody, really. So let's sum this up here. This is why I kind of say is that while Mythos or Fable and 5.6 Sol are very good at what they do, it's inevitable that there is some future model, Kimi 3 that was released in the last 3 weeks or so, or some future model that's just going to be much better, right? What's that?
The new Gwen model. There was a
Gwen.
new Gwen. Yeah. They got released.
So that's my thesis, Thad, is that the long game does favor the defenders because, for the short term, AI might make vulnerabilities exposed. It's easier to find a flaw than to actually fix it. So you just go back to what Mythos was reported to have found is 20-year bugs that existed in Windows Secure Boot, 20-year bugs that existed in the Linux kernel. These are things that are not easy to fix, right? But the longer term is that they will be fixed. And the longer term is that the defenders will have much better tools at their disposal in order to build better and more secure software. But we must really adapt to a new truth, is that, as I said at the beginning, guys, is AI use is optional for most organizations within certain domains, but it is non-optional in the cybersecurity domain. And if you think about warring AIs, where AI is being used as defense against attackers who are also using AI, then we're kind of in the realm of that William Gibson book, Neuromancer. So that is me today. But I'll stop my sharing, and we'll maybe hopefully take some questions for Thad or myself.
We do have a few questions for us, Craig, and just one comment on that last slide. I'll take a American sports euphemism here. Defense wins championships. If you looked at the last couple of Super Bowl winners or any of the major sports, it was their defenses that really shone out here. Yeah, they could score whenever. I think it's the same for NRL, although you and I probably don't know as much about NRL or AFL.
I'm Canadian, so I'm an ice hockey guy, but it is still very true.
Yeah. Anyways, first question from Adam here. When an anomaly is detected in a machine identity, how fast can automated revocation kick in before damage occurs?
That is a really good question. So I mentioned something called a harness, and that's where kind of it handles the orchestration of multiple agents. It handles traceability, and it handles kind of the business rules that would kick in when the agent kind of goes off the rails. So an anomalous agent might be doing something, trying to access something that it ought not to be. So how quick can you kick it off is really dependent upon what your harness is connected to. and what supporting tools behind that harness have the ability to. So remember I said, inventory, good governance, and then traceability. Those are the things, these are the magic pieces of this very complicated puzzle. So I hope that helps kind of give a high level answer to your question. And it was a really good question, by the way.
Caleb up next. Could AI prevent the world from losing practical end-to-end encryption?
Indirectly. So end-to-end encryption usually refers to symmetric keys. So if I share a key with that in advance, he and I can now communicate end-to-end encryption, right? But a lot of times, how do I get that key to Thad? Well, we have to do kind of a key agreement thing. Here's a piece of the puzzle. Here's a Thad's piece of the puzzle. And so one of the things, how does that relate to AI? Well, quantum computers are theorized to be able to break that key sharing scheme that I just talked about. And so AI, what does AI have to do with quantum computing? Two ways. One is it's helping build better error correcting practical quantum computers. That's one. And two, those quantum computers will run AI algorithms in order to kind of accelerate the ability for a practical quantum computer to break asymmetric key encryption. So there is a role there. Now, you'll hear a term called PQC, which is post-quantum cryptography or crypto agility, being able to kind of swap between classic crypto and PQC. One aspect is AI is also being used to attack the mathematics behind PQC. So there's a whole bunch of standards out there from NIST and other organizations that people are using AI to attack the mathematical assumptions that are being used to develop those new quantum safe algorithms. So interesting topic, interesting question, but
that could probably be our next webinar then, Craig.
Yeah, right. It's PQC. Yeah. And so that's my other remit at RSA, is helping drive RSA to be crypto agile and respond to our customers with great questions that Caleb just asked.
I'll jump into the next one, and then I think we wrap it up there. We'll try to come back for a couple others. We attended another webinar where we talked about browser security. Where would you rank the modern security matrix without the RSA bias? So
there's a browser security. So I'm not quite 100% sure what they're referring to. So RSA doesn't make browsers. So do we assess browsers for their security? So I can only give my personal opinion. And I would say from a security and privacy perspective in your own, say, personal life or from an enterprise, you've got Firefox, which is extremely good for your personal life. It has, uBlock and other type of tracking blocking built into it. And then on the enterprise side, the Microsoft Edge ecosystem is heavily tied into kind of the Microsoft Azure Entra ID security ecosystem. So it actually provides organizations some options for channeling secure information through within only kind of the Microsofty context. And that always requires cloud. If you're on-prem, different story entirely. I would recommend Firefox. But RSA has no bias in this because we don't assess browsers, we don't make them, we just use them.
Cool. Craig, I think let's wrap it up there. There's a few other questions. I'll try to message these people separately and maybe schedule a bit of a phone call.
Yeah.
Thank you very much to all of our attendees today, and thank you, Craig, for joining the team at Virtual Graffiti here as well.
Yeah, absolutely. Always a pleasure, Mr. Thad, and thank you everyone for joining and great questions. As stated, with the invites there, if you want to contact Thad and we can drive a little bit more into a catered briefing with you, happy to do that.
Awesome. Thanks everyone. Have a great day.
Thank you. See ya.
Thanks, Craig. Bye.